our last video, we were introduced to trigonometric reductions. So basically, we popped trigonometry onto the Cartesian plane here, and we saw that in each quadrant, we can find that some ratios are positive and some are negative. In quadrant 1, all are positive. In quadrant 2, only sine is positive. In quadrant 3, only tan. And in quadrant 4, only cos. And we began to see that we can actually allocate a quadrant based on an angle measurement that is given to us. And then from there, decide if we can reduce it to an acute angle that is either a positive or a negative trig ratio. Okay, and what I mentioned in that video is that we always work from the x-axis. So this is either 0 degrees plus or 360 degrees plus. That one's actually a little bit grayed out because it's not necessary to put that 360 plus. Okay, 360 minus is here in quadrant 4. So again, from the x-axis. 180 minus from the x-axis and 180 plus from the x-axis. But what happens when we take this y-axis here and we say, well, we know that this would be a 90-degree line, okay, 0, 90, 180, 270, and then all the way around to 360, okay? But what happens when we work from this 90-degree line either backwards or forwards? Okay, and that's what we're going to look at today because those are called cofunctions. So let's take a look just here in quadrant 1 because if you get this, you can actually apply the general concept anywhere. Okay, so we've said this is our 90-degree line and this is 90-degree minus and this would be 90-degree plus, right? Because it would be smaller than 90 degrees if you moved in a clockwise direction and bigger than 90 degrees if you moved in an anti-clockwise direction. Okay, what we know, let's have a look at this triangle here that I've popped down. This is normally our reference angle here. We come up from the x-axis to the line and we work in this triangle. Okay, so if I asked you for sine, cos, and tan, but we're going to focus on sine and cos for this one. If I asked you for sine and cos of the angle theta in this triangle here, okay, you would be able to work that out for me. So you would say sine is opposite over hypotenuse, and so you'd look at it and you go, the opposite here, that's the y coordinate, so that's y over r, and cos is adjacent, so that's the x coordinate over the r value. Okay, but now if we were to introduce this other angle here, and we said, well, actually I want to take an angle that comes from this y-axis here. Okay, this angle here would be 90 degrees minus theta, okay, because this is a right angle, and so there we have it. Okay, so now if I asked you in this triangle for sine and cos, let's have a look at what that would look like. So sine in the green triangle of 90 minus theta, let's see, I want opposite, so that is now in line with the x coordinate. That's the x distance. Do you see that? So x over the hypotenuse. The hypotenuse in this triangle is still there, the r value. Okay, and what about cos of 90 degrees minus theta? Let's see where that comes from. So cos is adjacent. That's this line here, which is the y length. So y over r. Okay, and now if we don't use opposite, adjacent, and a hypotenuse, what I'm hoping that you've spotted is that sine of 90 minus is actually equal to cos. And cos of 90 minus is actually equal to sine. And that's why these are known as cofunctions. So in our class diagram, if we then add these two things, so the 90 minus and the 90 plus, 90 minus here in quadrant 1, 90 plus in quadrant 2, what we need to know is that sine and cos then are cofunctions. Okay? So if ever I see a 90 minus or a 90 plus, I need to be switching those out. So let's have a look at these two examples here that we've been asked to simplify. So sine of 90 minus theta. So that's in quadrant 1. And we check, is sine positive or negative in quadrant 1? sine is positive over there. Okay, it's very important that that's the first thing you check. And then, because it was 90 minus, okay, that makes me think of cofunction. Cofunction. Okay, the minute I see 90, I think cofunction. And so this then becomes positive cos theta. I can reduce it using its cofunction value. Okay, cos of 90 plus. So once again, I'm seeing that 90, and I know I'm going to need to change it to a sine. But the first thing that I need to do is I need to check. In this 90 plus quadrant, is cos positive or negative? Okay, according to our cast rule, sine is positive there, which means that cos would be negative. So when I reduce it, it needs to become a negative. And then, because it's a 90, it becomes its cofunction, which is sine. Now we get to the fun part where we actually just get to apply this, and we can simplify things that start out as complicated as these two questions, and they actually become very straightforward. So sine 90 minus x over cos 360 minus x. Okay, I've got new cofunction knowledge plus a little bit of knowledge about reductions that we learned in the last video. So there's a little cast rule that we can refer to. Okay, sine 90 minus. I am going to get into the habit of the minute that I see a 90. I just want to highlight that for myself because I need to think cofunctions, okay? I can't jump straight to it. I first need to figure out if it's positive or negative, but that does need to be something that's on my radar. Okay, so sine in quadrant 90 minus, that would be here. Let's add that to this little diagram here. There's our 90-degree line, so 90 minus, 90 plus. Okay, so that would be quadrant 1. And in quadrant 1, all are positive. So that's great. It's going to become positive. And sine, because it's 90, needs to become the cofunction there of cos. So cos x over, in our denominator, cos of 360 minus x. So that's here. Quadrant 4 is cos positive or negative there. Cos is positive. So that's also going to reduce to cos x. And what happens when I have a cos x over a cos x? That simplifies and equals to 1. Okay, next up, we've got 4 to do, but straight away, I'm just going to highlight for myself, here's a 90, here's a 90. Okay, don't forget about those cofunctions. So sine of 360 degrees minus alpha. So we find our 360 minus quadrant, that's over here in quadrant 4. Is sine positive or negative there? Well, cos is positive, so sine is negative. So that reduces to minus sine of alpha. Then multiplied by sine of 90 plus alpha. Okay, 90 plus, that would be here. Okay, is sine positive or negative there in quadrant 2? Sine is positive, so that's going to be a positive when it reduces. And then it also needs to become a cofunction. So I'm going to change it, and it's going to be cos alpha over cos of 90 minus. So 90 minus, that's here, 90 minus. In quadrant 1, all are positive. Okay, so that's then going to just become a positive cofunction, sine alpha, multiplied by cos of 360 minus alpha. So let's have a look at what's happening there. 360 minus is here in quadrant 4, and cos is positive there. So that's going to be a positive cos alpha. And now, look at that. Because everything is multiplying, I don't have any weird adding or subtracting there. So I'm allowed to cancel. So I can say, well, sine goes into sine once, and cos goes into cos once. And what I end up with is that I've got a minus 1 times 1 over 1 times 1. So this just simplifies to a minus 1. Look at that. So we used our knowledge, and we really did simplify these complex looking examples. Let's see if we can tackle some more. Okay, here's another one. Cos theta minus 90 times tan of minus theta, tan 720 minus theta times sine of minus theta. Okay, what I'm seeing there is lots of negative angles. Okay, when we had negative angles, we said we add 360 because then we go a full revolution, and that helps us just to pop this onto the Cartesian plane. Okay, this one is also very big. So when we have very big angles, we subtract 360 degrees. Okay, let's get our cast rule on the page. Now let's take a look. I want to highlight this 90 because it's a cofunction, but normally the cofunctions work like this. We've got our 90-degree line, and then it's either 90 degrees plus here or 90 degrees minus. So this is back to front, which means this is actually a negative angle in disguise. So be careful of those. Let's see what's going to happen there. Okay, this is really a challenging one here. So it becomes cos, let's add 360 degrees there. So we'll end up with cos of 270, because that's 360 minus 90, then plus theta, times by tan. Here we're going to add 360, and it's going to help us to see which quadrant we're working in, over, let's see what's happening here, 720 minus 360. That leaves us with an answer of 360. So we can also just stop there. We can just subtract one revolution. Okay. And then here, sine of 360 degrees minus theta. Okay. Now this 270 is actually something new, and it doesn't often get asked, but it can come up. So look out for that. It works in the same way. So let's figure out where's 270 degrees. That would be this line here, right? Okay, and a 270 degrees plus would put us there in quadrant 4. So we still need to think about cofunctions. Okay, we had the root of that cofunction over there to start us off. So we still think about cofunctions, but now we're going to think about them in the 4th quadrant. Okay, is cos positive or negative in the 4th quadrant? It is positive, and then when I reduce this, it becomes its cofunction, which is sine. Okay, so it started out looking very complex, but I could apply the same principle. Then we've got tan in quadrant 4, 360 minus. Tan is negative there, so that's times by a minus tan theta, over, this is the same thing, tan 360 minus, so that's again a minus tan theta, times by sine in that last quadrant. So let's see, sine 360 minus is negative sine. Okay, be careful. You'll see when I've got more than one ratio written down here, the minute I multiply by a negative, I add brackets. It just helps not to make any mistakes later. Okay, this is also going to cancel so beautifully. So sine can cancel with sine, tan can cancel with tan, and so I'm left with all the ones, and then I just need to figure out positive times a negative is a negative on top, negative times a negative is a positive in the bottom. So that's going to give us minus 1 over positive 1, which is just equal to minus 1 there as our final answer. Okay, now they want us to simplify without using a calculator. So that should sound an alarm for us that we're probably going to use special angles. So there's the information that we need. Let's have a look. 290 degrees, that's somewhere here. It's bigger than 270, but smaller than 360. So let's rewrite that as 360 minus something. Okay, 360 minus 70, that'll give me 290 over cos 20. Okay, in that 4th quadrant, that 360 minus quadrant, sine is negative. So now we're going to say, okay, well that's then just minus sine 70 over cos 20. And now it looks as simplified as it can be, but have a look at what we can do. We can change one of these. Let's change the cos. It doesn't make sense to change both because then you just work yourself into a circle. So let's say it's minus sine of 70. I'm going to leave that like that. But I'm going to rewrite this here as 90 minus 70. Okay? Because 90 minus 70 does equal 20. So because I could see that these two add up to 90, it made me think about cofunctions. Okay? So now what I can do is I can say in the 90 minus quadrant, is cos positive or negative? It's positive, and then I can switch it to its cofunction. So this then becomes minus sine of 70 over sine of 70. And that just simplifies then to give us an answer of minus 1. Let's take a quick look at one last example here. Sine of 210. So I want to rewrite that. Okay, so sine 210 is 180 degrees plus 30 times by cos of 46. I don't know anything about 46, but it's an acute angle, over sine of 136. So we can rewrite that then. That's going to be 180 minus 44. Okay, so those two are not quite the same, but let's keep going. In the 180 plus quadrant, that's down here, sine is negative. So that's going to reduce, and it's going to be minus sine of 30 degrees. Okay, 30 degrees is a special angle. So that is at least looking promising for us over there. We're going to take y over r when it comes to it. Okay, then we've got multiplying by cos of 46 over sine in the 180 minus quadrant. That's there, that's positive. So that's then sine of 44 degrees. Okay, sine of 30 we've now said is y over r, so minus 1 over 2, multiplied by, have a look again, 46 plus 44, it seems so close to a special angle, but if you add them up, it equals 90. So once again, we can do the cofunction plan. So we can say, well, then let's rewrite this as cos of 90 minus 44 degrees, because that's what equals 46. Okay, over sine of 44, and then using our cofunction rule, we'll see it's minus a half times by, this is going to become sine of 44 over sine of 44. And those are just going to cancel, and so we have a final answer there of minus a half.